right, so let's talk about how you add and subtract if they do not have common denominators. And remember, the phrase that we've been using is factor first, factor last. Or, if you're in one of my other classes, some people like to say factor after, which is fine, okay? But either way, we want to factor first, because that helps us know what we need to put into each fraction. And then we also need to factor last, because that will help us know if we can remove anything from the final answer. That always makes it smaller, that always simplifies it, okay? So factor first, okay? When we do this problem, it isn't, I wouldn't necessarily call it factoring, but what we will do is we're writing it as its two factors. So the first thing I would do is I would break down this first fraction. 7's not going to change, but this is actually 3x times 3x. Okay, and that's going to help us out in a second, because we're going to ask ourselves what we need to do to adjust each fraction. So then we factor the second one. And right now we only look at the denominator, because remember, we're trying to get common denominators. So to factor the denominator, that would be a 3x. And then we have an x plus 1 left. The numerator hasn't been affected yet. Okay, so now we have factored or written the factors of each fraction. So now we have to get them to match. They need to be common in order for us to combine them. Adding and subtracting, we always have to have that common denominator. So when we do that, we ask ourselves, what is missing? All right, so so when we ask ourselves what is missing, let me set up each one. So if there's something missing, that means we need to put it into the fraction. So I'm going to rewrite this first one, and I'm going to leave a space in case we need to add something to that fraction. And then I'm going to rewrite this one. Oh, there we go. And I'm going to leave a space in case we need to put something into that fraction. So then we ask ourselves, okay, well, what is missing? If you look here, what is missing from this one that this one has? Okay, this one has a 3x, so does that one. But this one has an x plus 1 that this one needs. So since this is missing the x plus 1, that's what we are going to multiply in. So x plus 1 here, and then remember, in fractions, whatever's in the denominator, we need to also apply it to the numerator so that it actually doesn't change the meaning. All right? So then we ask ourselves the same question about this one. What is this one missing that this one has? And if you notice, they both have a 3x, but this one has another 3x that this one is missing. So since it's missing the second 3x right here, that's what we're going to multiply in this one, a 3x. Okay? And on top and on bottom. And I forgot to go ahead and rewrite the numerator, because that's still there. All right, so now our denominators match. They're in a different order, but that's okay. Okay, that's okay. We're going to rewrite it anyway. So our common denominator, it's all right. All right, so our common denominator is, there we go, much better. All right, is either one of those. So I'm going to write it as one big denominator, 3x times 3x times x plus 1. We only need to write it once, and now we're going to put both of these into the numerator. So I distribute that, and I get 7x plus 7. Then I'm adding this problem, so I get, I'm going to add it to these two when I put them together, which is 3x squared. Let me use the same color. All right, 3x squared. So now we would combine any like terms. In this case, there are no like terms. Here's our x squared, here's our x, there's our 7. But what we should do is rewrite it in descending order. So let's put our 3x squared first. Let's put our 7x second and our 7 last. It's 3x times x plus 1. Okay, and the reason why we do that is because we want to see if it'll factor. Again, factor first, Now we're at the place where we factor last, all right? After we get them to match and we put the terms together, then we need to check one more time to see if anything factors. So remember when we did this one, we did first times last. That goes into our x. So what multiplies to 21 and adds to a 7? All right, so the factors, pardon me, are only 3 and 7. Those don't add to 7, nor 1 and 21. So, lucky for us, we don't have to factor because that does not have any terms. So this is actually our answer. But you always have to check, okay? Because if we could factor, we could remove some of our terms. And that's what simplifying is. It's removing those terms. All right, so now we need to do the same thing here. I'm going to erase that just because we really didn't need it. And we're going to think of the same thing that we had here. Hold on one second. All right, so our phrase is factor first. Factor first. That way we can compare the denominators better. All right, so the way we factor this is the GCF. All right, and then we've got x plus 2 on top. And this time we're subtracting. This is just a trinomial. A lot of you guys like to make your x. So what multiplies to 3 and adds to negative 4? It's a negative 1 and a negative, 3. So that means that that factors to x minus 1 and x minus 3. And the numerator is just negative 2x minus 1. So then the other thing I want to do before I deal with the denominators, I really don't like subtraction. Subtraction can get us confused. We can accidentally make some mistakes. So I'm going to change the subtraction. Actually, let me do it with this color. I'm going to change the subtraction to adding the opposite of those. That way, it's really just adding positives, and it's going to go so much easier. We'll probably make less mistakes with our signs that way. So now, we've factored each of the denominators. Now we need to compare them so that we can get them to match. So let's go through 2 times x minus 1, and then x plus 2. That's our first fraction. And we're adding it to x minus 1 and x minus 3. But chances are we're going to need to adjust both of them. So again, we ask ourselves, what is this fraction missing compared to that fraction? Okay, well, it's missing the x minus 3. So that's what you need to tack on. If you do it on bottom, you have to do it on top, and that means you're going to have to multiply those binomials. So we'll have to do our Punnett square in a second, just to make sure that we get all of our terms for our binomials. All right, so then what's this one missing that this one has? Okay, and that's the 2. That's that GCF of 2. So I do that on top and bottom. And again, I forgot to write this numerator for some reason. 2x plus 1, because we changed the signs. And in this case, we are just going to distribute. Again, we need to put a grouping around the binomial. That way we see it as a couple. We see it as a group together. So when we multiply this one, we're just going to distribute in that case. All right, so now our common denominator is 2 times x minus 1 times x minus 3. All right, doesn't matter the order, because remember the commutative property says we can change their order as long as each factor is multiplying. So I just put the 2 up front. All right, then we need to multiply that out. A lot of times we use our box. So let me move these over. Let's do our box. So that's x plus 2 and x minus 3. So that's x squared, 2x minus 3x minus 6. So when we put those like terms together, we are going to have x squared minus x minus 6. And because we changed it to adding at the beginning, we're going to add this when we distribute, which is just 4x plus a 2. Okay? Let me rewrite that with a better marker. Hopefully you can see it better. Alright, so then we combine our like terms. Okay, kind of like here how we rearranged until we could factor. Same thing here. We need to combine our like terms and then see if we need to factor. So we combine our like terms. X squared is on its own. Negative x and 4x is plus 3x. Negative 6 and 2 is minus 4. Pardon me. Our denominator is still 2 times x minus 1, x minus 3. So now we need to ask ourselves, does this factor? Can we go off to the side? Sorry, I don't like being all over the place, but okay. Does anything multiply to negative 4 and add to 3? And in our case, it does. Okay, the two numbers that multiply to a negative 4 and add to a 3 from right here are a positive 3, excuse me, a positive 4 and a negative 1. Because those will add to negative 4, multiply to 3. So those are the two binomials that we're going to make. And then we're going to see if any of them will cancel. And if they do, then our hard work has paid off. So x plus 4, x minus 1, 2 times x minus 1 times x minus 3. And it did pay off because we noticed that an x minus 1 and an x minus 1 will cancel. So thankfully, something did cancel so that our factoring was worth it. So now we just have our numerator, which is x plus 4, and our denominator, which is 2 times x minus 3. And if you would like to distribute that, you can. But you don't have to. Since we're factoring, we're actually trying to break things apart into factors so we can reduce, so you don't have to put it back together at the end. Okay, so that is what we're doing. Common denominator. Remember, factor first, factor last. I factored here at the beginning. I factored here at the end. Okay, first and last. And we have to get that common denominator. What is the piece missing, or what is this fraction missing compared to that fraction? And remember, always look just at the denominators to answer that question.